Now I come into upsampling or interpolation. So what is upsampling? So upsampling means that fx, let us say fx is equal to 8 kilohertz, I want to make fy is equal to I is equal to 2, then fy will be 2 into 8 kilohertz, that means 16 kilohertz. So that factor I is equal to 2. So let us say I have a signal fx is equal to 8 kilohertz. So within 1 second of the signal there is a 8k sample. Now once I make it 2, then fy is equal to 16 kilohertz. So within 1 second I have a 16k sample, 16 kilo sample. So I have to double that number of sample. The same example, there is a 32 sample. So if I want to make it double frequency, the number of samples should be 64. So what we will do? In between two sample, I put a 0. Now if I want to make it 3 times, then in between two sample, I have to put 2 0. So number of 0 will be I minus 1. If it is factor 2, then 1 sample, 1 0. If it is factor 3, then 2 0. If it is factor 4, then 3 0. I have to put 3 0. Because factor 2 means I have to double the number of sample. Factor 3 means I have to 3 times that, when it is 3, then it will be 8 into 3, 24k sample in 1 second. So I have to make it 24k. So 8k to 24k. So in between two sample I have to put 2 0. Okay. So I minus 1 number of 0. So I can put 0. So there is a sample value, there is a sample value. I put a 0. So what I am doing? I am interpolating the curve. So upsampling is nothing but a interpolation. Downsampling is nothing but a discard. I have discarded the sample. So dissemination or disseminated the sample, discarded the sample. Here I am inserting the sample. So that is why it is called interpolation. Okay. So I know that upsampling means interpolation. So if the xn is the sequence, then the Vm is the upsample by 3 times, then I know in between two sample I have to put to another sample. Because I know the distance between the two sample here t is equal to 1 by fx. But here distance between the two sample, this is also a sample, this is also a sample. So this is my ty. So ty is equal to 1 by fy. I know the fy is equal to I into fx. So I put 1 by I into fx. So I can say ty is equal to t by I. So I have divided the duration but factor I. So that is why, so you know that if the sampling frequency increases, then the distance between the two sample is decreases. That is why it is decreases by I. So that is why I get more number of sample. So now if I say that, what will happen in frequency domain? Now if this is my, let us say, spectrum of a signal. So this is 0, this is 2 pi. Let us say, when I upsample by factor 2, I get 2 mirror image. This is 0, this is 2 pi. So number of mirror image will be, so if it is factor 3, I get 3 mirror image using 0 to 2 pi. If it is factor 4, I get 4 mirror image between 0 to 2 pi. So I can say I have to analyze in frequency domain and what I have to restricted it. So that means I have lot of image I have given. I am getting two image. So when I say the two image I am getting, but what I want a single image. So somehow after upsampling I have to remove this multiple image. So what we have to do after upsampling, I have to pass through again a low pass filter, because 0 to pi I interested, not this portion I am interested. So again I required a filter, low pass filter, whose cutoff frequency is pi by I, because it is 2 times, so it is pi by I, pi by 2. If it is 3 times, that will be pi by 3. So that means pi by I. So after that upsampling, I required a filter whose cutoff frequency is pi by I. So I discarded all the other images, I am only kept the single image. So that is upsampling diagram. Okay. Now let us say what will be given. So spectrum of Xn is equal to this one. So spectrum of Vn, Vm will be multiple, so this line will be not, Vm will be multiple of Xn, so mirror image of Xn will be there. So I only want this portion. So I designed a low pass filter, kept this portion, rest of this portion are discarded. So that is my requirement. So that is why upsampling also followed by a low pass filter. In case of downsampling, first low pass filtering, then downsampling. In case of upsampling, after upsampling, I have to reduce that mirror image. That is why I have to put a low pass filter to get the signal. Okay. So that is the upsampling diagram. Now the spectrum of the upsample signal contain not only the primary band of interest from, but also the image. So I have to reduce those image by a low pass filter 0 to mod of x is equal to pi, 0 to mod of y equal to pi by a. That means minus pi by I to pi by I. Okay. Now let us say here, let us say this is my j omega x minus pi to pi. So after I equal to 2, I will get 2, that what I said, if I equal to 2, I get 2 mirror image. So this to this is 1 and this to this is another one. So within 2 pi, I get 2 mirror image. Okay. So instead of that, I want only single one. So I will kept this portion and this portion will be discarded using a low pass filter. Okay. So and again it is called anti-aliasing filter or interpolation filter. Recover the primary band of interest, instead of all other band is discarded. So I know it is equal to I. So it is I. So this is equal to pi by I. So how this is coming? Let us say, so I know that my interpolation filter, the upsampling block diagram is look like this. X of n, fx is the input sampling frequency, v of m and then h omega and y of m fy. This is my upsampling block diagram. So x of n is the input. So I know v of m is nothing but a x of m by I, because if x of n is equal to 1, 2, 3, 4, 5, then I know if d is I is the upsampling factors, then I have to know I minus 1 number of sample I have to insert it in between that. That means that you know that in case of x of n, distance between the two sample is t. So it is nothing but I can say n, when I write xn, it is basically it is x of n into t. Now my ty is nothing but a t by I. So my y of m, when I say, it is nothing but a y of m into t by I. So t I am not writing. When we are writing discrete signal, we do not write this t. But I know that index is divided by I. So I know v of m is nothing but a x of m by I. So m equal to 0, I know it is x of 0. Then x of 1 I cannot get, but 1 by, let us say I equal to 2. So x of half, can I get it? That is why x of half is nothing but a 0. Then I get the sample at x of 2 by 2, which is nothing but a x of 1. So that is why I said in between two sample I put a 0. So how do I put a 0? Using this function. But in case of a downsampling, we said y of m is equal to v of m into d. We have discarded that, we have not taken up. Here I am not discarding, I am putting 0 in between two samples. So if I say I equal to 3, so I am putting 2 0, I equal to 3. So what will happen? So if I say I equal to 3, I will take another slide here. So when I say I equal to 3, so I said v of m is equal to x of m by 3 else 0. So that means I am selecting v of 0 is equal to x of 0. v of 1 is equal to 3 is equal to x of 1 by 3. So this is not else. So this is 0. Then v of 2 by x of 2 by 3 0. v of 3 x of 3 by 3 is equal to x of 1. So let us say I have a signal x of m is equal to 1, 2, 3, 4. So I can say v of 0 is equal to x of 0 is equal to 1. v of 1 is 0, v of 2 is 0, v of 3 is equal to 2. So in between the sample 1 and 2, I put 2 0. Understand? Similarly, x of 4, v of 4 is 4 by 3 is 0, v of 5, 5 by 3 0, v of 6, 6 by 3, x of 2 is equal to 3. So in between 2 and 3 sample, I put another 2 0. So upsampling means, the meaning of the upsampling is v of m sequence is generated from x of n, selecting the signal index which is integer multiple of I, and elsewhere it is 0. Now I can say, let us say what is Vz? Vz is nothing but a Vm into z to the power minus m. So what is Vm? X of m by I, elsewhere it is 0. Z to the power minus m into 0 is nothing but a 0. So x of m by I into z to the power minus m. So again if I change the index, so it will be x of m and this will be z of minus mi. So I can say this is nothing but a x of z to the power I, because zi whole to the power minus m. So zi act as an z. Now x of zi, now I know the Vz. Vz is equal to x of, instead of x of z, it is x of z to the power I. So if I say z is equal to omega, so v y omega. So I know z is equal to e to the power j omega. Okay. So Vz is v omega y is equal to x. X is omega x. So omega x into I. So it is e to the power j omega y into I. So I said omega y into I. Z is equal to e to the power j omega y. So this side is omega y, that side is z to the power I, so it is omega y into I. Now this signal will be low pass filter by a filter. So filter impulse response is m k dash, so k dash is equal to k, again it is nothing but index changing kl, so it is nothing but h1 m minus kl into xk, because this is omega, this is x of z to the power I, or I can say Vm is equal to x of m by I. Okay. Now I can say that what is the value of this constant. So when I say that this, what is the output of this filter? So what is the filter? So H I omega, so I require a filter which is instead of 1 omega y less than equal to pi by I equal to, instead of 1 I want this should be C, C is a constant, otherwise it will be 0. So I can say I require a low pass filter which this will be C up to pi by I, after that it will be 0. So minus pi by I to minus pi by I to plus pi by I, it will be C, that I want. So how do I get the value of the C? I know y, if you see that y is nothing but a C into x of, so what is y? Yz, I can say yz is nothing but a h of z multiply by x of z, v of z. So v of z is nothing but a x of z to the power I. So I know that is nothing but a x of omega y into I, and hz I want a constant. So hz is constant and x of omega I know. Now what is initial value theorem? So I can say y0, power of the output. So output power and input power will be same. I have an sampling rate conversion system. Input power is, I cannot generate the power, so power will be same. So I can say y0, so DC power y0 is nothing but a 1 by 2 pi summation of all the spectra. So I summing all the spectra. So it is nothing but a C by 2 pi x of y I but else are 0 into dy. So I can say that C by I, because you know dy. So it is x of omega I, omega y into I. So omega x is equal to omega y into I, because you know omega y is equal to 2 pi f by fy. Fy is equal to I into x. So I know omega y is equal to 2 pi f by I into fx. So it is nothing but a omega x by I. So I know omega y into I equal to omega x, and omega y into I, that means divided by I. So omega x divided by I will become here. So it is C by I x0. So I know that constant is this C is nothing but a C by I into x0, which must be equal to I. So for better, so I can say the I is equal, or C is equal to I into y0 divided by x0. So in normalized cases, the C must be equal to I. So if the C is I, then Hij is nothing but a I. So Yz is equal to I into x of z to the power I. Or I can say the frequency response y omega y is equal to I into x omega y. So I is the interpolation gain. I is called interpolation gain. Is it clear? So I is called interpolation gain. Now I said upsampling, downsampling I know. Now I said fractional rate conversion. That means suppose I have an fx is equal to 8 kilohertz, I want fy is equal to 12 kilohertz. That means I know that fy by fx is equal to 12 by 8 is equal to nothing but a 3 by 2. So, I have to upsample by 3 times and downsample by 2 times. So, this is called fractional rate converter. So, how do I do the fractional rate conversion? So, in this case upsample by 3 times. So, here I equal to 3 and downsample by 2 times. So, you know the upsampling means upsampling followed by a low pass filter, downsampling means low pass filter followed by a downsampler. So, upsampling followed by a low pass filter, downsampling means low pass filter followed by a downsampler. Now, this is a low pass filter, this is also a low pass filter. This low pass filter cutoff frequency is pi by I, this low pass filter cutoff frequency is pi by D. So, can I combine these two low pass filters? Yes, I can combine these two low pass filters. So, let us say I combine this low pass filter, then what should be the cutoff frequency? So, pi by I and pi by D. So, whichever will be the minima, because I have to rest. So, if it is let us say I equal to 3 and D equal to 2. So, if it is pi by 3, then it support pi by 2, because pi by 3 is less than pi by 2. So, I can say if I restricted the output signal of the upsampler is pi by 3, it will support the restriction of pi by 2. So, that is why I said minima of this is required. In case of let us say I equal to 2 and D equal to 5, then the output minima will pi by 5 only, because I have to the input which can accept by the downsampler is only pi by 5. So, I cannot produce a output which is pi by 2. So, cutoff frequency is the minima, whichever is the minima, but yes, I can combine these two low pass filter in a single low pass filter. So, input is Vp and output is Wp, and then it is passes through a disseminator. Let us analyze the system. First time domain, then frequency domain. So, time domain analysis. So, I know what is Vp. What is Vp? Vp is nothing but a upsample by I. So, I can say Vp is equal to x of n by I, else it is 0. And let us the low pass filtering is Hp. So, once is the Hp, then what is the output of the low pass filter? Vp as a input and low pass filter, and output is a convolution. So, I convolute the Vp with low pass filter Wp. So, this is the convolution. Okay. Now, I final output after downsampling. So, then Wp is downsampled by D. So, now Wp is downsampling. I know Ym is equal to Wm into D. So, I can say it is nothing k equal to infinity h of md. So, p is changed to md ik into xk. So, if I explain in pictorially what will be the time domain factors, let us say pictorial I will explain it. So, I will take a slide here. So, I have a signal x of n whose sampling frequency is fx is equal to 8 kilohertz. Now, I want to make it fy which is equal to 12 kilohertz. That means upsample by 3 and downsample by 2, I equal to 3 and D is equal to 2. Upsample by 3, that means 8 into 3 and downsample by 2. So, it is 24 and downsample by 2 means 12. Okay, done. Now, what is the suppose now let us x of n is equal to like this. Let us say 1, 2, 3, 4, 5, 6, 7, 8, all are the sample values, all are the sample values. So, x of 0 is equal to 1, x of 1 is equal to 2, x of 2 is equal to 3. So, I know this. Now, what is upsampling? Upsampling by 3, that means in between 1 and 2 I put 2 0, I minus 1. So, 3 minus 1 means 2 0. So, now if I say Vp is my upsample signal, V is my upsample signal. So, I know V0 is equal to 1, V1 is equal to 0, V2 is equal to 0, V3 is equal to 2. Because V of m is equal to x of m by I, else 0. V of 4 is equal to 0, V of 5 is equal to 0, V of 6 equal to 3. So, in between two sample I put 0, 2 0. Then I have done the filtering. So, filtering does not change the index of the signal. Okay. So, I get the same V signal, Vp, V of m is passed through a filter. Filter only change the characteristics of the signal, the lengthwise there will be no change. Then after the filtering, Vm plus the Vm after filtering I get Wm. So, this is equal to, let us say Wm, filter is equal to 1, let us say. So, I get Wm. So, Wm also I will get. Once I get the Wm from the Vm, then I have to get Ym. Ym is downsample by 2. So, that means I am not taking all the sample. So, let us say Ym is equal to Vm. Let us say that Vm or Wm is equal to Vm. Let us say that Wm is equal to Vm. Let us consider filter is equal to 1. Let us say filter basically multiplying the Vm with 1. So, now I can say Ym is equal to W into 2m, because D is equal to 2. So, I am selecting Y. So, Y0 is equal to W0 is equal to V0. Y1 is equal to W2 is equal to V2, which is equal to 0. So, I am selecting this sample, then Y2 is equal to W4, which is equal to V4 is equal to 0. So, this sample. So, while I am doing multi-rate or fractional upsampling and downsampling both, in that case I do not require to compute all the interpolation. I can only compute this signal, this V, this V, this V and this V. Other V's are not important to me. So, now if I give you another signal, let us say I give you x of n and then I give you that I equal to 2 and D equal to 3, then if the Vm is equal to Wm, compute the sequence of Ym. You can do that. Okay. Now, what is happened in frequency domain? So, in frequency domain, I know Wp, that if you see the diagram, what is Wp? That it is nothing but a Vp multiplied by the filter. So, Wp is nothing but a Hwp, W omega p is nothing but a filter frequency response multiplied by the Vp frequency response. I know V frequency response omega p is nothing but a x of omega p I, because it is upsampled by I. Okay. So, Wp is equal to xi into xwpi, that I know for upsampling filter. Now, for downsampling filter, what I require, yw is nothing but a 1 by d into k equal to 0 to d minus 1 w into dy minus 2 pi k divided by d. Now, for imaging, to reduce the image after filtering, what I want only wy by d and 1 by d. So, 1 by, I can say omega y is equal to 1 by d into w omega y by d, where w omega y by d is nothing but a I into xp, the omega p by I, omega p I. So, I can say that it is nothing but a I by d into x of omega y divided by d. Or if I say omega p, then omega y is equal to omega p into omega y is equal to I by d into omega x. So, if I set the omega y instead of omega y omega x, then I have to put is I by d into omega x here. So, it will be I by d square. So, the frequency response I by d is the amplification factor. So, I is equal to 3, d is equal to 2, so 3 by 2, then omega y by d is the output. So, in terms of frequency, let us say I have an 8 kilohertz signal. So, maximum frequency content is 4 kilohertz. Now, once I say upsample by 3 times, that means 24 kilohertz. So, maximum frequency content is 12 kilohertz. Then downsample by 2 times, that means 12 kilohertz. Maximum frequency constant is 6 kilohertz. Understand or not? So, it is nothing but a 3 by 2 into 4. 4 kilohertz is the input. So, 3 by 2 into 4, that is 6 kilohertz. Okay. So, this is the frequency domain representation of the upsampler and downsampler both combined. Okay. Now, so summary. So, summary of the fractional rate conversion by I by D. Interpolation process, interpolation proceeds dissemination as the spectrum of the intermediate signal y1 should be at least contain all the component of the original spectrum. The composite filter has a gain I. This is due to the interpolation. Now, if you see, if Fy is greater than Fx, then the low pass filter acts as an anti-imaging filter. So, Fy is greater than, so input is Fx, output is Fy. So, if Fy is greater than Fx, that means it is upsampling. So, in case of upsampling, ultimately it is upsampling. So, in case of upsampling, the job of the filter is to remove the multiple image. Now, when Fy is less than Fx, that is downsampling, the job of the filter is act as an anti-aliasing filter. Okay. So, now suppose I give you a problem, write down the fractional sample rate conversion signal flow diagram or the block diagram for converting sampling frequency to, let us say, so I have a signal x of n, sampling frequency of x of n is equal to, let us say, 10 kilohertz. Write down the functional block diagram of a fractional signal sampling rate converter to convert to y of n with a sampling frequency Fy is equal to, let us say, 25 kilohertz. So 10 kilohertz input, 25 kilohertz I want. So in that case, what I will require? So I know Fy by Fx is equal to 25 divided by 10. So which is nothing but a 5, 2. So 5 by 2. So I by d. So I is equal to 5 and d is equal to 2. So I know this is my x of n. Upsample upward array by 5 times. Then I know low pass filter LP. Then I know it has to be downsample by 2 times and I get y of n. So this is Fx, this is Fy. Upsample by 5 times, downsample by 2 times. Is it clear? Similarly, I can give any arbitrary number and I can told you draw that signal flow diagram or block diagram of the fractional rate sampling rate converter. Now, if I told you that suppose x of n is equal to 1, 2, 3, 4, 5, then what will be the y of n? So, upsampling is 5 means I is equal to 5. So, I minus 1, 5 minus 1 means 4 0 in between 2 samples. So, there will be a 1 0 0 1 0 0 0 0 2, 4 0 in between 2 samples. Now, downsample by 2, downsample by 2 means MD, M into 2M. So, this 1 skip 1, this 1. So, the Ym will be 1 0, then this skip this 1 0, then 2 will be skipped, 0 will come. So, like that. Okay, let us say LP is let us say this one is if it is Vm, and if it is Wm, let us say Vm is equal to Wm. LP does not change that sampling Vm Wm sample value, but basically it will be changed because of low pass filter. Interpolation will happen and the samples will be changed. So, I can say that it is nothing but a summation of 2 or 3 field. Let us say LP is nothing but a summation of successive 5 samples. So, you can do that way. Okay. So, that is upsampling, downsampling and fractional sampling rate conversion. Next topic will be implementation of that upsampler and downsampler in a digital scenario. How do I implement it? How do I implement the low pass filter? Okay. So, next class I will talk about the implementation of those things. Okay. Thank you.